Morning. So this is Dr. Dinesh Kumar Koli, and in this today's video lecture, we will study about the working of mercury in glass thermometer. So this is the mercury in glass thermometer, and this is the basic instrument for measuring of temperature, and it is studied in the first or second semester in basic mechanical engineering subject for the first year. Now, what is the basic construction of this mercury in glass thermometer? So, a mercury in glass thermometer, it is which is used for the temperature measurement, and this instrument consists of the a valve that serves as a container for the working liquid and allows for easy expansion and contraction of the liquid's volume. So in this mercury in glass thermometer, mercury is used as the working fluid, and when we use the valve which containing the mercury fluid, it takes heat, so its expansion occurs. Second part, a stem. So stem is nothing, it is a glass tube with a small capillary attached to the valve. A small capillary tube is attached with this valve and extended at the bottom into a valve that is partially filled up with the working fluid. So the capillary tube is attached with this, the measuring valve. Third is a temperature scale. So the temperature scale that serves as a display for the temperature reading, because when we are going to measure the temperature, definitely we have to take a reading. So a temperature scale here on the glass tube is serves as the temperature reading, and essentially a preset or imprinted on the stemper it is made of. The ice point is most frequently used as the point of reference for the calibration. So when we are going to measure the temperature, suppose we are going to start with the 0 degree centigrade or the Fahrenheit, so the ice point is considered as a reference point for this scale. A liquid used for the working purposes, it may be alcohol or it may be mercury. The mercury is most commonly used, the liquid for this mercury in glass thermometer. At the top, an inert gas, primarily either it may be nitrogen or it may be argon, is inserted of mercury in a thermometer to reduce amount of mercury that volatilizes. If the mercury volatilizes, then it absorb it to reduce the its mercury for the safety purpose. Now, these are the basic parts of our thermometer. This is the picture of the thermometer. So you can see here the parts which have been discussed here of the thermometer. You can see it is very easily. This is at the top side. It is called the safety valve in which nitrogen or argon is filled. This is the capillary tube which is containing the thermometer, which is the mercury which is shown in the black color, and this is the valve which is having the mercury. This glass stem, it is a covering tube which covers the whole thermometer, and here you can see the scale in Fahrenheit. This is the scale which is used for the reading of the temperature. The mercury column is there. So these are the parts of the thermometer: a safety valve, a capillary tube in which the mercury column rises, a glass stem which covers the whole thermometer, and a temperature sensing valve in which the most of the mercury is filled here, which gives the temperature response or thermometric liquid. Now, how this thermometer works? Actually, the measurement of temperature is basically on the basis of the thermal equilibrium. So how we measure the temperature? So for measuring the temperature, when a thermometer is positioned close to hot object, or the object of what temperature is to going to measured, such as a body whose temperature has to be monitored. The responding liquid inside capillary tube will enlarge in volume. Definitely, when a object whose temperature is to be measured, it is brought in contact with the measuring bulb, so the heat transfer will occur from the temperature measuring body to the mercury in the thermometer. And because mercury is the metal, and all the metals on getting heat they expand, so the expansion of the mercury will occur in the capillary tube. You will see it makes the liquid rise because the surface area of the capillary is very small, and it is constant also. So because of the volume rise of the mercury, the liquid column will rise in the capillary tube. Increased liquid volume will cause a noticeable rise in the liquid level since the capillary tube surface area is very small. So the column will rise, and we can easily see the rising of the column in the capillary tube. The temperature will be determined by the amount of mercury columns free surface moves. So the free surface column moves up to a certain height depending upon the temperature of the measuring body, and it takes some time because when the heat transfer occurs from the body whose temperature is going to be measured to the mercury, so until there is a temperature gradient, the heat transfer will be continued. And when the temperature measuring body as well as the mercury both will get the same temperature, or we can say thermal equilibrium will reach, the heat transfer will be stopped, and the column in the thermometer will be stopped. It will show a certain level, and that reading is taken at that condition. It is called the thermal equilibrium. So a calibrated scale for this purpose inscribed on the glass tube outside. So on that scale we can use the measurement. The thermometer, which is the mercury thermometer, is basically used up to the temperature measurement of around 390 degree centigrade. For the high temperature measurement, use the thermocouple and other device, and for the very high temperature, use the pyrometer, etc. So this is about the brief discussion on the this use of thermometer. Thank you.